Getting your parting tool too high can cause a lot of heat, and if you don't have a carbide parting tool, that would not be good. It could ruin your parting tool. Getting it too low certainly increases the chances of your parting tool snapping off and ruining the whole job. The trick is to get it right on center. And if you machine the end of your part and eyeball the top of the tool to that little dot in the middle, you usually come pretty close. But that's a little bit of trouble. So I found a little bit better way to do that, and we're going to talk about that right now. I've come up with this little device that sits on the saddle. You slide it across the saddle over the top of your parting tool, like so. And if the little light comes on, you know you've got it nailed. There it is. If you don't, simply have to adjust until the light comes on and you know you're there. And you can build one of these. They're fairly simple to build, and we're going to go through the process right now. All right, the most difficult part I found about making this was the square cylinder here. I'm going to take the end cap off. The end cap is made out of aluminum. It's got the little spring in the end, just a hole drilled. You could even use a pen spring here to push against the negative end of the battery. The battery itself, this one is a Duracell A23 battery. That slides into the hole here. And what we did is we used a letter Y drill to drill this hole, and we drilled it all the way through, right out the other end. And then we took a tap, 7/16 20 tap, and put a thread in here to accommodate this little cap, which also has, of course, the 7/16 20 thread on the end. Now what we needed to do now was have a contact for the positive end of the battery. And to do that, we used a piece of plastic tubing. I think this is supposed to be 3/8 tubing, but it's a little bit short of that, but it really doesn't matter. Because what we're going to do is turn down on the lathe. I used a brass plug, but a copper plug would even be better, to push in the end of here. And it fits in fairly tightly, but at the end of the plug it's a little bit larger so that it will not push in all the way. So you have a short section of this tubing with that brass plug in the end, and in the very end of the brass plug I drilled a small hole. The small hole is to accommodate the end of this green wire, which will be soldered into that hole. And then what we can do is, you can probably see that right here. Here's the end of the plastic tubing sticking out. We push that into the hole, and we had the battery in there, and we had the cap on at the time that we pushed that in there. And pushing on this, you can feel the pressure of the spring. And we clamped it right there, but we also put in epoxy inside here to hold everything, and as soon as it dried we were ready to go in that respect. Now we'll take a look at the top end of this. The way we got that part made. Now for the second part, we have a stem here that could be 1/2 by 1/2 also, or a little bigger if you'd like. And that simply provides us with the right distance from your saddle, which is underneath this block, to the top of the square pillar here. Now we can't use metal for this part on top because the LED that we used has to be isolated. Now we'll get a little closer so you can see this. What we've done is put a little plate in here after milling a slot or a step out so that the bottom of the plate is parallel to the bottom, parallel and flush to the bottom of the plastic that you're going to use here. This is actually a piece of an old cutting board. Now we'll get a little more light on the subject here and perhaps give you a little bit better view of that. Underneath here, on the underside of the plastic, we created a channel. We used an end mill to create a small channel for the wire to pass through. The wire comes out the other side of the channel, moves across and connects to one side of the LED, and the other side of the LED is then soldered to the underside of this plate. Now under this plate we also have a channel that provides clearance for that wire and the little bit of solder that it required. And then we took the metal plate and epoxied it to the plastic and put it in the vise and held it there until everything dried. So the way that works now, let's see if we can't find a piece of wire and just show it to you. Alright, we'll slide the battery in here, making sure the positive end goes first. Put our cap on. You can feel the tension when it hits. And then we'll take a little clip here. Touch one clip to the base, and then touch the pad, and on comes the light. And there you have it. Now you will need to know which side of your LED leg takes the positive current. So if you take your LED and put a couple of clips on it, one on each side, and we'll just assume that the side with the red lead is the positive side. We don't know that. And we take the positive side of the battery and connect it to the red, and of course the negative goes to the black. And nothing happens. So that leg is probably not the positive leg. So if we turn the LED around and clip these clips to the opposite legs and again run our little test, the light comes on. Therefore the red clip side is your positive side. And you want to make sure that your battery is fed to the positive side as it goes up to your plate.
If you'd like to be notified of other new modifications, please click on the subscribe button. Thanks for watching.